Alright, so in a previous video I went over wall bouncing, and it was brought to my attention that that didn't make much sense when we dealt with the set actor rotation. And I'd like to actually explain this node in general a bit better. So the first thing to understand, or the first thing to notice, is I have changed this true value from 360 down to 0. Technically this doesn't matter, and I will demonstrate in just a second. So what this set actor rotation is doing is it's coming into our current character blueprint and literally setting our rotation to either, let me close this, either 0 or 180. It is doing one or the other. 0 facing in a right direction, 180 facing in a left direction. We're going to just quickly notice too, if we were to set it to 360, oh, we're back to facing in a right direction. And now we don't need to worry about 360 anymore. We're only going to focus on 0 and 180. So where this gets a little bit confusing from traditional thinking is with an add rotation. Typically, we think when we deal with rotation, we are just adding one of these numbers to our current rotation. So if we were to get 180 degrees out of this right now, you would think, oh, we're just adding 180 on top of the 0, and now we're facing in a left direction. And that's not true with the set actor rotation. We are only setting it to either 0 or 180. There is an add actor rotation where you would add on top of whatever rotation you have or subtract rotation to still create a seemingly left or right facing character, but that's not how I've set it up with this node. We are only using 0 or 180. We are not adding, we are not subtracting, we are setting it to this value or this value, and it is setting it literally right here. Now, to go a little bit deeper on the actual wall bouncing, we use the get actor forward vector. If we hop in here, we look in the top left, I've made a debug that will help to explain this a little bit better. When we move in a right direction, we see our forward vector is 1 and our z rotation is 0. I just showed you that with a z rotation, we are having our character face right. Now, if I go left, we see that's flipped. Forward vector of -1, z rotation of 180. Perfect, that makes sense for what we just explained. Where this gets confusing is if I go on a left wall, I'm wall sliding with a forward vector still of -1, z rotation of 180. While my sprite wall sliding appears to be looking in the opposite direction, that is just purely visual. That has nothing to do with any physics or anything. And we see once I land, I'm still facing in a left direction with that forward vector of -1, z rotation of 180. And the opposite is true over here. We see that I have a forward vector of 1, z rotation of 0 on a right wall. Now, when I want to wall bounce, I'm going to want to jump in the opposite direction. So if we watch this number up here while I wall bounce, we see that it's flipped. The rotation has flipped, and the forward vector is now going in the opposite direction. Same here. Boom. 1 and 0 from that -1 and 180. And that's what this is doing. We are getting the forward vector. We're seeing when it's less than 0. So when is it less than 0? When we're moving left or we are on a left wall. And if that's true for the context of a wall bounce, if this is true that we are less than 0, we want to set our rotation to 0. Previously I had it at 360, and this still functions because remember, 360 is equal to 0. It is a full rotation technically. We're going to ignore that though. We're going to just say it's 0. So it's true, it's equal to 0 now. And that creates that desired effect where we wall bounce. And if it's false, that means we are not less than 0. That means we are moving in a right direction with a forward vector of 1. Then we will select 180. And we will wall bounce off of the wall. Now, remember, if we do not actually have this node, we will quickly see that we don't go off of the wall because our launch is based off of our forward vector as well, and it's just shooting us up because we're not rotating. We're still keeping a forward vector of -1, so our logic thinks that, oh, we're just needing to go up. So we want to make sure that we literally flip this value in here. We set this to 0 or 180 to make sure that we do in fact create our nice wall bounce feel. And there we have it. I hope that can help to make sense a little more. If you have any questions, please feel free to ask.